So string is not
Hey everyone, welcome back, and let's write some more neat code today. Problem on lint code, because this is a premium leak code problem and we can solve it for free on the website lint code. And also, this is a problem from the blind 75 list, a list of 75 common leak code questions that we've been tracking on this spreadsheet. The link to this will be in the description if you want to take a look. And we're pretty much done with the main problems. I'm going to be solving another one today, a premium one in code and decode strings. This is a pretty decent problem to understand, so let's get into it. So it's a bit of a design algorithm because we're going to have two different functions that we want to implement. So we're given a list of strings and we want to write two functions. We want to encode this list of strings into a single string. And you can kind of see that down here. We were given an input list of strings, lint code love you, and we want it to be a single string, such as this one in the bottom right. And then the decode is just going to be the opposite of encode. We're going to be given a single string, and we want to be able to convert this string back into that original list of strings that we were given. And it's up to us on how we want to design this algorithm. But the tricky part is going to be that the basic assumption is that in our input, we could have any possible character in the inputs, not just limited to lowercase a to z. So the difficult thing is going to be, how do we create some kind of delimiter between each word? How do we know when one word ends and another word begins? That's kind of what we're going to be focusing on. So let's get into that solution. So suppose we were given two strings like this, neat and code, and we want to convert it into another string, basically into a single string, right? So a naive way would be something like this, right? Just say, okay, neat code. Now the problem is, okay, we did that, the encode was fine, but now we want to decode this back into the two original strings that we had, but there's no way for us to determine, right? Because we can't remember where one word ends and another word begins, right? So we need to have some kind of character or something to separate words. What if we used a pound sign or something, right? Something like this, or any character, maybe a question mark or something, right? But this is like our special character. That's what's going to separate words for us. So in this case, it works out, right? We'll go character by character in the input. Once we get to a pound sign, okay, we'll say that this word ends. So we'll say, okay, we have the first word neat, and this is not included in any of the words, so we skip it, and then we get to the remaining portion, code, and there aren't any more pound signs, so that works out in this case, right? But basically, our assumption when we're using this pound sign is that the pound is never going to actually show up in any words. What happens if we have a word, suppose in our word code, in the middle of the word, we have a pound sign, right? There's no reason why we can't have something like this. So in that case, when we take this and encode it, we're going to get something like this as the encoded string, right? And then when we split it, we're going to have three different words, neat, co, and de. But in the original, you can see we only had two words, but when we get our output, we're going to end up splitting this into three words, which is not what we wanted to do, right? We want to transform it back into what was originally given to us. So having just a single special character delimiter is not going to work, because that delimiter could actually show up in some of the words. Wouldn't it be nice if in the encoded string, we somehow already knew how many characters would go in the first word, how many characters would go in the second word, etc., etc. So then we could just say, okay, let's take the first four characters, encode it back into the first word, then take the next five characters, encode it into the second word. So how could we, do something like that? Well, one way would basically be by maintaining some kind of array, right? When we're given this inputs list of strings and we want to encode it to a single string, we can, for every single word, basically have an integer, right? The first word is 4 characters, the next word is 5 characters, etc. But then where are we going to store this list? Because this is a valid solution if we're storing this list somewhere, but basically in the description, they don't want us to store any kind of state variable. This encode and decode needs to be stateless. So when we have this list 4, 5, we cannot store it in a separate data structure. Is it possible for us to store it in the string itself? How about when we're encoding this, we want to know, okay, starting at the beginning here, how many of these characters are going to be in the first word? Well, why not just put that number at the beginning, right? 4 at the beginning of this encoded string. That works because then we can look at the beginning, transform it into an integer. But one thing is, what if the word itself had some integers in it? Well, now we need another delimiter, right? We're going to have our integer always at the beginning. There's always going to be an integer at the beginning. The string is always going to start with an integer. That integer is going to represent what the length of the following word is going to be, but we're going to have a delimiter in between the integer and between the word itself. So basically, we're going to read each character until we reach the delimiter, and once we reach the delimiter, we're going to take all the characters that we just read, which are going to be transformed into an integer. So this 4 is going to be mapped to 4, and then we're going to count the next 4 characters after the delimiter, which in this case is going to be pound. And that works because we're only going to read one delimiter. We're going to expect a single pound sign no matter what, right? So even if the first character here was a pound, it still works because we're going to read an integer 4, read a single pound sign, and then say, okay, take the next 4 characters, even if they include pound, even if they included some integer like 8 or 6 or something, right? If they include integer, pound, it doesn't matter because this tells us how many characters are going to be in the first word. And then once we read those 4 characters, what are we going to expect to be next? Well, we're going to expect some word, but we want to know how long that word is going to be. So we're going to do exactly what we just did over here, having an integer followed by a pound sign, and we're going to put that same thing over here. So in this case, we're going to have a 5 and a pound sign because the next word is going to be 5 characters long. So this is kind of how we're storing the integers inside of the encoded string so that we know how to decode it. We know how long each of the strings is going to be. So I hope this makes sense. Now I'm going to show you how to actually code it up. By the way, the overall time complexity of encode and decode is going to be O of n, where n is going to be the total number of characters given to us in the list of words. So with that being said, we are ready to get into the code. Okay, so now let's get into the code. You can see the interface is a little bit different. Yes, we are doing this on lint code rather than LeetCode because it's free on there. So let's start with the encode function. It's a little bit easier. So remember, we're given a list of strings and we want to encode it into a single string. How are we going to do that? Well, we're going to go string by string in the input. And to the result, we want to append this encoded string s. How are we encoding it again? Well, remember, we're going to take the length of the string, and the length of the string is going to be an integer, but we want to transform that into a string. So let's do that in Python pretty easily, just like this. Plus, we want to add the delimiter, the pound sign. So we have the length of the string followed by the delimiter pound sign, followed by the string itself s. So then, this is kind of the format that we agreed upon. This is how we're going to be encoding it because it's going to be easy for us to decode this as well. So we're going to do this for every single string in the input, add it to the result, and then we can go ahead and return that result. So encode was pretty straightforward. Decode is going to be a little bit more tricky, but we know the rules that we can follow. So this time we're given a single string, a single encoded string, which is going to be, encoded using the function that we just wrote. So how are we going to decode it into a list of strings? In this case, our result is going to be a list of strings. And I'm also going to have a pointer I, which is going to tell us what position that we're at in the input string so far. So I'm going to just iterate character by character. So while I is still in bounds, we are going to read character by character, basically decoding each string. So when we start off, the first position that we're going to be at is going to be an integer, right? So what we want to do is we want to find the delimiter. We want to find the end of the integer. So we're going to have a second pointer, j. Initially, it's going to be at I, and while the character at pointer j is not equal to the pound, meaning that we're still at an integer character, we're going to keep incrementing j by 1. And we're guaranteed to find a pound character, right? Because right? So what we want to do is we want to find the delimiter. We want to find the end of the integer. So we're going to have a second pointer, j. Initially, it's going to be at I, and while the character at pointer j is not equal to the pound, meaning that we're still at an integer character, we're going to keep incrementing j by 1. And we're guaranteed to find a pound character, right? Because that's kind of how we encoded it up above. So we're going to keep incrementing until we get to that pound character. And then once we get to the pound character, we know that our integer, the length of the following string, is going to be from our string starting at index I, going all the way up until index j, but not including index j, right? So this portion is going to be the integer. Right now it's a string, so we want to transform it into, or convert it into an integer. We can do that in Python pretty easily, just like this. So now this length variable tells us how many following characters we have to read after j in order to get every character of the string. So in other words, if we start string at index j plus 1, because remember, j is at the delimiter character, so j plus 1 is going to be the first character in the string itself, and we want to go all the way until the end of that string. How do we get that? Well, right now we have the length of that string, so we can say j plus 1 plus length. This will give us the entire string. And what do we want to do with the string? Well, we want to append it to the result. So let's go ahead and do just that. So basically,